Ramos. I'm first reporters for group. Our topic is all about reciprocating engine. Learning objectives. Understand the basic principles of operation of a reciprocating engine, mainly as it used for aviation applications. Appreciate the factors that affect the shock power that can be developed from such an engine and how to read an aircraft piston engine performance chart. Understand the basic operational principles of a propeller, including the methods used to calculate its thrust, the power required in its efficiency. Know how to read and interpret a propeller performance chart. Piston engines and propellers. Reduction. The rotary and radial taps were the first types of piston engines to be used for airplanes. Today, such engines are obsolete for use on production airplanes and have been replaced by flat, horizontally opposed engines. Such reciprocating piston internal combustion engines drive a propeller and are often used to power relatively low to moderate performance general aviation airplane types. An example of Piper Cherokee airplane is shown in the photograph below, which has 4-cylinder 160 HN 119.3 kilowatts horizontally opposed piston engine driving a fixed pitch propeller. The advantages of this propulsion system are that it is reliable, affordable, and provides reasonable propulsive efficiency. However, the system is not readily scalable because the power-to-weight ratio of a piston engine decreases rapidly with increased power output, making it unattractive for larger and heavier aircraft. In such cases, a turboprop engine will be prepared if a propeller is to be used. A Piper Plane 28 Cherokee, flown by Dr. J. Gordon Leachman, was photographed over the western Maryland countryside. Piston engines, including the higher efficiency afforded by types of diesel, may also be suitable for certain classes of drones and UAVs where the required flight range and/or endurance cannot be achieved using batteries alone. By using hybrid propulsion systems, one of the most common systems combines a gasoline, petrol engine, or a diesel engine with electric motors, which can be operated purely on diesel or electrical power, but using both when needed to this end. Engineers must understand the basic principles of aircraft piston engine operation, including the effects of density, altitude under power output, and specific fuel consumption, as well as the associated propeller performance under the conditions of flight. Reciprocating piston engines. The first type of piston engine used for aircraft was a rotary engine, which saw extensive use through the 1920s. In this type of arrangement, the cylinders are arranged in the radial configuration that radiate outward from a central crankshaft. Like the spokes of a wheel, as shown in the figure below, it also resembles a star when viewed from the front, so the type is sometimes called a star engine. In a rotary engine, the entire crankcase and its attached cylinders rotate around it as a unit along with the propeller. The pistons are connected to the crankshaft using a primary and assembly, and the remaining pistons and their connecting rods are attached to rings around the primary rod. The air fuel inlets are connected to a carburation system, and the exhaust outlet are connected to the radial manifold. Closing using a cam. In some versions, a carburetor delivers the fuel air mix into the crankcase, reaching the cylinders through transfer ports, so only exhaust valves are needed. Rotary engines and radial engines. Thank you, sir. Next.
Good day, sir. I am Carangelo B. Avila, the second reporter. Most early aircraft use rotary or radial engines. The rotary engines' gyrotropic issues and limited scalability made it almost obsolete by 1930. One advantage of the rotary engine design is good cooling because the cylinders rotate. However, a significant disadvantage is the large gyroscopic moments on the aircraft. from the rotating engine mass. This characteristic led to the several serious issues with the flight handling qualities of early aircraft, the ability to turn only in the one direction. The radial engine is another early reciprocating piston engine used to power many pre-1950 airplanes, as shown in the figure above the photograph below. The radial engine has fixed cylinder and the propeller is connected to the crankshaft. The inlets are connected to the carburation system and the exhaust outlets are connected to a system of pipes. In the radial engine, gyroscopic effects on the airplane are much lower than for the rotary style of the engine, in which cylinder rotate with the propeller. Consequently, radial engines were much preferred over the rotary type, which became obsolete for aircraft use after World War I. A radial engine design has fixed cylinders that radiate outward from a central rotating crankshaft to which a propeller is attached. Powerful radial engines with 12 or more cylinders have been built for aviation use, mainly for airplanes constructed through the 1950s, raising power output levels from 2,000 horsepower to 4,000 horsepower range. In addition, extra rows of radial cylinders can be added to increase the engine's power. However, this approach rapidly drives up the engine's weight and also results in cooling challenges for downstream rows of cylinder. The most powerful piston aircraft engine ever built was the Lycoming XR7755, which had 36 cylinders and had a shaft power output 5,000 horsepower. But this engine never saw use on an airplane as shown in the figure below. Modern piston aero engines for aircraft are usually flat, horizontally opposed. The horizontally opposed engine configuration is also known as a boxer or a flat engine. In this design, the cylinders are arranged in two banks on opposite side of the crankshaft, forming a flat and wide configuration which allows for a more streamlined and aerodynamic profile. This is important for minimizing drag and also allows for efficient air cooling. Several manufacturers, including Lycoming, Teledyne, Continental, and Rotax, produce piston engines suitable for aircraft use. They are manufactured with 4, 6, or 8 cylinders with power ratings from about 125 horsepower to 600 horsepower. They come in normally aspirated and supercharged forms and carbureted or fuel injected variants. Fuel injection is used for higher performance engine. A 6-cylinder horizontally opposed reciprocating engine for aircraft use. The engine drives a propeller mounted directly to the crankshaft.
Good day, sir. I'm the last reporter. My name is Baclaan. Superchargers and turbochargers are forced induction system used in aircraft engines to increase the intake air pressure, allowing for better combustion and improved engine performance. Supercharging or turbocharging may be used to increase the power of a piston engine and maintain its power output to higher flight altitudes. This is a good solution for higher performance aircraft despite the penalty of some extra engine weight and maintenance cost. As shown in the figure below, superchargers are mechanically driven by the engine through a bell connected to an accessory
auxiliary drive from the crankshaft. Turbochargers are driven by the engine exhaust gases and, and consist of a turbine and a compressor connected by a shaft. The exhaust gas spins the turbine, which in turn spins the compressor and forces more air into the engine and hence into the fuel management system. Turbochargers are generally more efficient than superchargers because they harness waste energy from the exhaust gases. Superchargers and turbochargers have been used to maintain the power output from aero engines. On some of the earlier high-powered radial engines, they were both combined in a system known as turbo supercharger. Superchargers and turbochargers can maintain the power output from aero engines to higher flight altitudes. While modern pistons aero engines are mechanically reliable and robust, one concern is that they are relatively heavy compared to their power output. Their power-to-weight ratios are relatively low, which are only about 0.2 horsepower to 0.4 horsepower. Therefore, when such engines are required to produce higher power levels, they can become prohibitively heavy for use on an aircraft. This reason is why a turboshaft engine is usually necessary to drive a propeller. After a specific power requirement for flight is reached, a turboprop has a much better power-to-weight ratio of about 0.8 foot-pound to 1.2 foot-pound, while turboshaft engines have a higher capital and maintenance cost per hour unit. Their better specific fuel consumption and reliability make them very attractive for larger propeller-driven aircraft. Work example, quantifying a unit of horsepower, the output at the shaft of an engine is often measured in horsepower, which is given the unit symbol HP. This unit is attributed to the Scottish engineer James Watt, who wanted to compare the power output of his steam engines to what horses could do to help market the engines. Watt did various experiments and determined that a typical farm horse could, on average, steadily lift a 600-pound weight over a pulley system for an average distance of 63.9 feet in an average of about 69 seconds. Using the information explained how James Watt came up with a result that 1 horsepower equals 550 foot-pound. The work done by the farm horse will be the force it pulls, the distance it pulls it. So with a weight of 600 pounds hanging over a simple pulley, that is also the force applied. Therefore, F equals W and W equals Fxd equals Wxd equals 600 times 63.9 equals 38,340 pounds. So, mo siyang formula, sir. This latter value is roughly the power produced by a horse, and James Watt settled on 1 horsepower equals 550 foot-pound. Note, Watt was not worried about accuracy, all he wanted was a simple but representative quantitative measure of the power delivered by a horse relative to what his steam engines could produce so that he could market his engines more effectively. In addition, the term made sense to farmers and others using horses to move equipment. And so, for a steam engine of 10 horsepower, the purchaser knew that they were buying a machine equivalent to what could be done by 10 horses. The unit of horsepower has since and today use measurement of unit of power output. That's all, sir. Thank you.